Okay, so how does one computer bug, and I mean just one, a single flaw buried deep inside millions of lines of code,
Somehow end up causing, wait for it, $10 billion in damages? I mean, that sounds completely impossible, right? But it happened. Let's get into it.
This is the story of EternalBlue. It's an absolutely wild ride about how a secret government cyber weapon got leaked to the public, unleashed total chaos, and what it really tells us about just how fragile our digital world is. All right, so before we can really get into the chaos, we have to get on the same page about a few things. We've got to understand the basic building blocks that turn a simple coding mistake into a full-blown weapon.
So everything kicks off with what's called a vulnerability. And the best way to think about it is like a crack in a castle wall. It's just a weakness, a flaw. By itself, it's not really doing anything, it's just kind of sitting there, waiting. But that harmless-looking crack becomes a huge problem when someone builds an exploit. The exploit is the tool. It's the battering ram that's custom-built to smash right through that specific crack. It's the thing that turns a what if into an, oh no, this is happening right now.
So let's just hammer this home. A vulnerability, that's potential risk, a latent flaw. But the second an exploit shows up on the scene, that risk is now critical. It's an active tool, a practical threat. This is the exact moment a simple bug levels up and becomes a weapon.
Okay, so how do they actually forge one of these digital weapons? Let's peel back the curtain and see how attackers take something as simple as a program crash and turn it into a seriously sophisticated tool.
You know, it's not just random hacking. There's a real process here. First, they analyze a crash to figure out what's really going on under the hood. Then, they build what's called a proof of concept, just to show that, yep, this bug can be controlled. After that, they write the payload, that's the nasty code that does the damage, and finally, they wrap it all up and polish it into a reliable weapon.
Now, obviously, our computers aren't just sitting ducks. They have defenses, and a really big one is called ASLR. What it does, basically, is it shuffles a program's memory around every single time it starts. So for an attacker, it's like trying to hit a moving target. In the dark, from a mile away. It's really hard.
But attackers are always clever. They came up with this brilliant and, frankly, terrifying technique called return-oriented programming, or ROP for short. Instead of trying to sneak their own code in, they just use what's already there. They find little, perfectly legitimate snippets of the program's code, they call them gadgets, and they just chain them together to do whatever they want. It is exactly like making a ransom note out of cut-up magazine letters. Genius, right?
And this really just shows you the endless arms race in cybersecurity. It's a constant back and forth. Defenders build a wall, like DEP, to stop attackers from running code where it shouldn't. So, attackers invent ROP to get around the wall. Then defenders build ASLR to move the targets around. And what do attackers do? They just figure out a new way to find the targets. It's this never-ending, high-stakes game of cat and mouse.
Which brings us, finally, to EternalBlue. And this, my friends, is where all that theory becomes terrifyingly real.
So what did EternalBlue go after? It targeted a flaw in a really core part of Windows called the Server Message Block Protocol, SMB. All you need to know is that this is the basic stuff that lets your computers talk to each other on a network, for sharing files and printers. And the exploit gave an attacker a golden ticket to run literally any code they wanted on a vulnerable computer, completely remotely.
Okay, pay close attention to this timeline, because it's the key to the whole story. March 2017, Microsoft releases a patch. The good guys fixed the problem. But then, 1 month later, a mysterious group called the Shadow Brokers leaks the NSA's own exploit for that very flaw, EternalBlue, to the entire world. And then, just weeks after that, WannaCry hits.
WannaCry was this nasty ransomware worm. It used EternalBlue to spread like wildfire, automatically jumping from machine to machine, locking up files, and demanding ransom. We're talking hospitals, businesses, entire infrastructure ground to a halt. The damage? An estimated $4 billion. But believe it or not, that was just the warm-up act.
Because just a month after WannaCry, something far worse showed up. It was called NotPetya. It used the exact same exploit to spread, but this thing, it wasn't after money. And the damage it caused? A staggering $10 billion.
Yeah, see? Here's the twist. NotPetya only looked like ransomware. In reality, it was what we call a wiper. Its real purpose wasn't to get a few bucks in Bitcoin. It was designed for one thing and one thing only: pure, irreversible destruction. It would permanently scramble the master boot record, essentially turning computers into very expensive paperweights.
So you have to ask, right? How could this possibly have happened? How could it have been prevented? What do we learn from a disaster of this magnitude? And here it is. This is probably the single most important thing to take away from this whole story. The patch was there. Microsoft had already released the fix 2 full months before WannaCry even launched. This means the disaster wasn't just some super advanced technical failure. It was an operational failure. It was, plain and simple, a preventable catastrophe.
So what does preventing this look like? Well, it's not some magic bullet. It's the boring foundational stuff. It's patch management. It means actually having a plan, figuring out which vulnerabilities are the most dangerous, and automating the updates. It's about sealing those cracks in the castle wall before the enemy even knows they exist.
Another huge one is something called network segmentation. The ship analogy is perfect here. You know how big ships have watertight doors? It's the same idea. You break your network up into smaller, isolated pieces. That way, if one part gets breached, you can slam the digital doors shut and contain the damage, preventing it from taking down the whole organization.
So in the end, the story of EternalBlue really leaves us with this one nagging question. The patch was there, the defensive strategies were well known, and yet the catastrophe happened anyway. Which really makes you wonder, is our biggest vulnerability the technology, or is it us?